Okay, so we're going to talk about kinematics, that is, motion described with mathematical models. So first of all, what's a mathematical model? Well, this is a model of a boat. I have a sail, some kind of hull, a keel. All of these different symbols represent something in reality. So how this part relates to this part relates to this part is represented in this model, the drawing. Well, this is also a model, except these symbols represent motion, that is, how fast something is moving in a certain direction, the elapsed time an event takes, the acceleration is the rate of change of motion, and finally the distance, that is, how far something moves in a certain direction. All of these variables represent real phenomenon in the real world. So it's described as a mathematical model because there is an equal symbol, multiplication, exponential notation, summation, that is, adding two things. All of these mathematical processes you're familiar with from algebra class describe how these different physical variables relate to each other mathematically. So that's why it's called a mathematical model. It represents something in the real world. Before we do any of the math, though, we should understand the basic language of kinematics. And it starts really with origin. That just means the beginning. So whenever you describe where something is, you have to describe the beginning of your distance measurements. So I'm going to call this 0 centimeters along this number line, and this point is 5 centimeters away, 10 centimeters away, 15 centimeters away. Where an object is called its position. You can call it D or you can call it S. I'm just going to call it X because we're moving horizontally here. That's the traditional variable for horizontal. Distance is how far you've changed your position. So if I move from 0 to 10, the final position is 10 and the initial position is 0, and I've moved 10 centimeters. So the distance I've moved is 10 centimeters. However, if you take away the absolute value symbol, then you have displacement. So displacement is the same idea, how far an object has moved, except in a certain direction. So now if I go from 10 centimeters to 0 centimeters, the final position is 0 and the initial is 10, so the subtraction gives negative 10 centimeters. That means I've moved 10 centimeters towards the origin. That's called displacement. How far an object is moved in a certain direction is called displacement. Because direction is included, it's called a vector quantity. Distance has no direction, so it's called a scalar quantity. Speed, I'm sure you're familiar with, is how fast something moves. So you simply take the distance it moves and divide by the time. Well, I should probably have included time in my little vocabulary. Time is just how long an event takes. So maybe this is in focus, maybe not. That's 6, 7, 8, 9, 10. The time in between my finger snaps is approximately 1 second. So if I go from here to here, that is, if I move 5 centimeters in 1 second, the distance I've moved is 5 centimeters and the elapsed time is 1 second. So your speed is described as 5 centimeters per second. If you take away the absolute value symbol, then direction matters. So here to here in 5 centimeters, in 1 second that is 5 centimeters per second. But if you move from here to here, then the final position is 0 and the initial is 5. So final minus initial is negative 5 centimeters per second. So velocity, again, is how fast you're moving in a certain direction. Speed is just how fast you're moving. So as distance is to displacement, scalar to vector, speed is to velocity, that is, motion and motion plus direction. Scalar quantity is speed, vector quantity is velocity. Finally, acceleration is the rate of change of velocity, so how quickly you're changing your motion or the direction of motion. So final minus initial is such an important concept. It gets its own symbol. It's called delta. So we have final velocity minus initial velocity divided by the elapsed time is the acceleration. So those are 7 or 8 important kinematics vocabulary.